Alright, in this video we're going to demonstrate how to design and export a file out of Snocad software to cut parts, cores, templates, or other pieces for your skis and snowboards using our CNC Multicutter machine or another similar CNC router. I'm not going to go into great detail on how to do anything in the software packages with the exception of actually exporting the files and setting them up to cut. We will have other videos with more detail on that in other sections on our website and YouTube channel. Anyways, to start, I'm going to open Snocad, and on the screen I have a typical ski design, and what we're going to do is set it up to export 3 different templates. When I design skis or snowboards in Snocad, I typically like to design 3 different files for export. One is actually the full shape of the ski or snowboard, or the outline shape of the ski or board, and I use that to make a template that I use subsequently to apply edges to the ski base or snowboard base before I laminate the board. By having a template that is full size of the ski or the board, you can compare your fit of the edges to make sure everything's perfectly straight and the correct size as a quality control check before you actually do the layup. So it's kind of an important template to have. The second template I like to export, or file I like to export, is for the base material of the ski or the board. Now the base material template's a little bit smaller than the actual ski shape. It's got to be a little bit smaller because of the width of the steel edge. Typical skis and snowboards use edges that are approximately 2 millimeters wide. So if we were to make a template that's 2 millimeters narrower than this all the way around the perimeter of the ski or board, it would allow for the fit of the steel edge. I'm going to assume that you're going to do a full wrap steel edge around your ski or your board and not have little notches where you fit the edge partway up the tip. For doing that, Snocad does not have the ability to do the little notch bases, and you would have to export your file to another CAD package and do a little bit of work. I'll demonstrate that in another video on the website. But for this case, we're doing a full wrap steel edge. The third template I'm going to export is one for the core, and the core template or core cutting file needs to be a little bit narrower even than the base template, because your sidewalls are typically anywhere from about 6 millimeters to 10 millimeters wide in most skis and snowboards. And I'll demonstrate all 3 of those right now. The full outline shape is the easiest to export. All you do is go to the File menu, choose Export DXF, turn off everything except the main outline because that's all we want, and click Save. Now I'm going to rename this file to Ski Outline. And also notice where I'm saving it. It's getting saved in my Documents folder, and that makes it easy to find later. You may want to design or designate a certain folder like called Ski Designs or whatever for all your different files. So if you do that, you just navigate to a different folder and save it, so it's easy to find your files later. The other thing I recommend is that you do a really descriptive name for all your files, because if you have 10 different skis that you're manufacturing or whatever, it can get confusing as to which ski outline you're talking about. So you should name it. In this case, maybe this is a 173, so I'm going to actually rename this 173 ski outline. And that way I know that it's the outline shape of my 173 ski, and if it's a 173 GS or Freeride or Freestyle, you know, whatever, name it like that. Save, and that's all there is to it. We've now exported some CAD geometry in DXF format that pretty much any program can read to either cut parts or a template file using that is this shape. The second file we want to export is our base template, and this Snocad software has a really clever little mode on it called the core editing mode. And even though we're going to be exporting a base template file, we can use this core editing mode to design the geometry 2 millimeters smaller than the ski shape in order to give us the offset necessary for the steel edges. When you are in the core editing mode, you then open up under the Tools dialog box the Core Shaper. It opens up a secondary dialog box that gives us a few different sliders to change a bunch of different parameters. The 2 we're concerned about for our templates in this case are the core sidewall width here, this slider, and you can see as I drag it to the right, the sidewalls, the white portion on the screen gets really wide, and as I go narrower it gets smaller. So you can determine whatever you want the sidewall width of your file to be by dragging this slider. The other thing you have to be concerned about is the tip spacer type over here on the right, and for a base template it absolutely has to be set as sidewall. There's these other choices which can be used for the core template later that I'll demonstrate, but for this base template, leave it set at sidewall. Now, as I was saying, typical steel edges on snowboards and skis are approximately 2 millimeters wide. So by dragging this slider down until we say 2 millimeters, you'll now notice that the little white offset here is now skinny, and it is basically 2 millimeters wide around the whole perimeter of the ski. So it corresponds to a perfect template or base material file that's 2 millimeters narrower than the ski. Now, in some cases, the edges we sell are actually 2.1 millimeters wide, so this would be a slightly too big template, but 0.1 millimeters is a few thousandths, is almost an irrelevant amount. And Snocad does not give you the luxury of doing a decimal 2.1 millimeter offset, so we're going to use 2 millimeters as the closest equivalent to make it easy. If you want to be super exact, what I would instead do is take the outline shape, put it in another CAD package where you can do a little bit more accurate offset and do the same thing. But Snocad makes it really simple, and many of you will not have an expensive CAD package to do other work in. So for all intents and purposes, the amount of error here is pretty negligible, so I would just set it up at 2 millimeters. And at this point, all you got to do is close out this dialog box, go File, Export DXF. And again, now this time we want to turn off the main outline and all the other things. And the thing we want to export is the core outline, because we want the smaller shape to be the geometry that's exported. Oops, inserts is still turned on. And I'm going to name this 173 ski base shape. And this could be used either to cut bases or a base template. I actually like to cut templates sometimes instead for cutting my materials, and use a hand router to cut them rather than the CNC, but either way, this file will cut either type. Click Save, boom, and that's all there is to it. Now, the third file I like to export is for the actual core itself. And there's a few different choices we need to make here, and I'll go over them right now. Go back into the Tool Core Shaper mode, and you're back to this dialog box. The first thing you want to maybe determine is whether you want to do a tip-through tail wood core, where the wood runs right up the tail and right up the tip of the ski to almost the very end. This gives a very lively type of a ski, super high performance, lots of pop. A lot of the freestyle and park guys like stuff like this. Or you want to do a ski that has maybe a radial offset where there's a little less wood and a little more plastic that gives us a somewhat more quiet ride on the snow, but still has a little bit more snap. The Snocad has a few cool little features where you can change this radius tighter or smaller by dragging this slider. And you can also change the overall length of the tip spacer material. In this case, you don't really need to change that or anything like that. Same thing on the tail, you get a radius thing where you can change that. Third type you can do is an interlock, where it's basically the sidewall shape, but it has these little notches that go into the core that allow you to sort of jigsaw puzzle the tip fill a little tighter on your skis. So if you're doing a layup in your mold where you do not pre-fasten your tip fill to the core, this helps hold everything in place in the mold, so it might be a way you want to do it. I generally don't use this, but it is used, and Snocad includes it as a feature in the software. Straight is actually one of the more common ways to do tip fill material on your ski, where you'll have a big long rectangular piece of tip fill in the nose and the tail of your ski. And this tends to give a very dampened ride because the plastic tends to radiate less frequencies through it when vibrations are going through the ski. It tends to be a little quieter on packed and icy conditions. So this is often used in a GS or carving ski where it's going to be used in hard pack conditions, or East Coast icy conditions will tend to give you a little bit quieter ride. I tend to like to do skis like this because I'm old and I'm not as much of a shredder as I was back in the day. But anyways, just you have to make the decision what type of core you're going to do first. And then the second decision you have to make is the width of the sidewall material you're going to be using in your ski and the board. Most commonly used sidewalls sold by snowboardmaterials.com and some of our competitors online tend to be 10 millimeters wide. So obviously if you're doing a 10 millimeter wide sidewall in your snow, you would think, okay, I would need a sidewall width of 10. That would work correctly, but you need, if you do that, it's got to fit your base exactly. Super exact registration, super exact material tolerances, and that's difficult to do sometimes in the molds. If you've ever laid up a lot of skis, everything gets epoxy all over it. It's hard to see what's going on, and unless you have a really tight registration system, it's hard to get perfect. What I often do to make things a little easier on myself is I'll change the sidewall offset on the core to 8 millimeters or so. And what that does is the white sidewall here is now only 8 millimeters wide on the ski, but if I'm using a 10 millimeter wide actual piece of sidewall, when I attach this to the core, it's going to be about 2 millimeters wider than the ski all the way around where it fits. And that makes it really easy to have overhang for trim, registration in your molds and everything like that. It just makes everything a little easier to fit and finish, and still gives you lots of sidewall on the ski for angled sidewalls and stuff, so you don't end up with wood exposed or any, and still seal up the ski correctly. So I typically set this at 8, but that's at your discretion depending on how wide your sidewalls and how you like to trim your skis or boards out. So in this case, we're going to set it at 8. And like I said, I'm going to set this up instead of a sidewall shape with the wood tip through tail core. I'm going to set this at straight. So what's going to export is basically the wood shape here that's kind of rectangular on the ends with an offset for the sidewalls of 8 millimeters. So I'm going to close this out, go back to my File Export DXF menu. And again, you want to choose the core outline and turn everything else off. Name the file correctly so you know what it is later. And this is ski core. And note where you're saving it again. Again, mine, I'm saving it just to the default documents directory, and save it. And that's all there is to it. That's all 3 files that I would typically export for my ski or board design. One thing I should note that Snocad does also have a core thickness mode in here where you can export this geometry. I find that I don't particularly like the data that it exports in any usable format for me to actually make a core file. So I kind of ignore doing thickness in here. I might design the profile just to look at it in the file, but to actually do the core thickness geometry, I'll do that in a different package and demonstrate it in a different video. I just find this data just doesn't do much for it, so that's why it's being ignored at this point. So after we've produced the different geometry files out of Snocad, you want to import them into some other package so we can set the files up to actually cut something with them. For doing base material or templates, I have found that the package called Sheetcam is a CAM package out of the UK. Is a great little package for doing that. It has a really simple interface, and it works really well with Mach 3, which is the driver package that I use on our CNC machines, and most inexpensive CNC routers tend to use it as well. So it's a good choice, and it's what we include with our machines. So I'll demonstrate that now. So Sheetcam has a whole bunch of setup you have to do ahead of time that I'm not going to demonstrate in this video. All your options for your job, your machine applications, bits, and everything like that. That's not really what I'm going to go into too much in this video. I'll do a little bit of the actual setup where it's concerned with actually doing the G code. But the Sheetcam specific video we have elsewhere will have more detail on setting it up. Anyways, in terms of these 3 templates we just made, or 3 files we just made in Snocad, I'm going to import the outline template first and set it up to cut a piece of 1/2-inch MDF to make a typical ski outline template that I would use for edging my skis. So go to the File menu. I'm going to go Import Drawing and then navigate to my Documents folder where the geometry is sold. So here it's in my Libraries Documents folder. This dialog box has a few different choices of file formats. You want to make sure it's set at DXF. If it's at one of these other settings, it won't even show you the DXF files in that folder. So I want to set it to DXF. And I just need to scroll down until I find my 173 Ski Outline DXF file, choose it, and open it. It opens up a dialog box here. I want to set my scaling at metric because Snocad exports their DXF files in metric. And then the other thing you need to be concerned about is where it's going to open it up on your drawing space. I typically set it up to import right in the center of the table of my CNC. And so I choose the center thing and click OK. Now you'll see that the template opened up sideways, and if you remember when you're designing the skis in Snocad, they're actually horizontal like this. It's a real easy fix to change that. Down here in the right hand corner there's a little menu here that says degrees, and you simply select and type in 90, hit enter, and then you'll see that the geometry file rotated into position correctly. Up here, these are your zoom keys. You click the zoom to extents, and that shows you the ski on the screen. Now, in this case, I've set up this red in the job options as it's a 330 millimeters by 180 millimeters, and it could either be a piece of MDF, which we're going to do in this case to cut a template, or it could also be the size of the base material you want to trim this ski out of. But anyways, that's set up in one of the dialog boxes elsewhere. But since I'm going to cut a template in this case, it's all ready to go. The gray indicates the size of my CNC router's cutting area. Our CNC multi-cutters have a cutting area of 400 millimeters wide by 2010 millimeters long. So that's what the gray area it represents in this particular screen. So the first thing, now that we've got our geometry in here, that we want to do is choose a tool to cut it out with. For cutting templates, I typically use either a 1/2 inch straight cut or a 3/8 inch straight cut bit. And I've designed a tool here, which I'll set up under the tools menu. My tool number 3 is a mill router 9.525 millimeter diameter router bit. And 9.525 millimeters corresponds to the metric equivalent of 3/8 of an inch. So it's basically a 3/8 inch straight cut bit. And I'll open up the edit tool menu here, right click that, open it up, and it opens up a dialog so you can see what all the settings are. In this case, it's the type is a mill router bit. They have other ones, drill, V cutters, tapping heads, etc. But of course, since this is a cutting bit, you want to set it up as mill router. The tool number is number 3. The diameter is set up as 9.525 millimeters. That's the actual diameter of the tool. The flute length is basically, the flutes are what are the blades on the actual cutting head, the length of them. And in this, the particular bit I have has 1 inch blades on it, and the metric equivalent of that is 25.4 millimeters. We set the tool length offset to 0. Right now, the depth per pass, meaning every pass around this template file, the way it's set up now would be 1.4 millimeters, which would be perfect if you're cutting out 1.4 millimeter thick base material. But in this case, I actually want to cut 1/2 inch MDF or 12.7 millimeter thick MDF to make a template. So I'm going to change this number to 12.7 millimeters. And you can see it updates. Feed rate. Our CNC multi-cutter machines, I recommend using a feed rate of anywhere from about 1500 millimeters per minute to 2500 millimeters per minute, depending on the material you're going to cut. In this case, because it's 1/2 inch MDF and we were going to cut it in one pass, I'm going to slow it down just a little bit so we aren't torquing on the machine too much. I'm going to slow it down to 2000 millimeters per minute. But that's generally dependent on the stiffness of your machine, the torque handling your motors have, and the chip rate removal your bit can handle. Most of you, that's going to be, all that stuff is way over your head, and you can cut slower or faster with this machine, but in general 2000 works pretty good on our CNC multi-cutters and typical small CNC routers. The plunge rate is how fast the bit drops down vertically into the material. I tend to set that lower at a rate of anywhere from about 150 to 300 millimeters per minute, so it sort of drops in slowly and doesn't torque on the bit and create a little notch in your template or your base material because the bit kind of grabbed a little bit as it entering the material. There's another dialog here for ramp angle, where you could angle into the material instead of just plunging straight in. I actually prefer to do a straight in drop, particularly because I also use the Donic blade cutter on this machine, and for cutting out die cut pieces, you typically want to drop straight into the material with a plunge, not ramp into it. Otherwise you waste some material because you don't get unless you're just using the male or the female part of your material. Anyways, for this example, leave ramp angle to 0. Spindle speed, the default is 1000 RPM, but my machine actually has a router on it, not a spindle, and the router has just got an on-off switch, and any speed control is actually controlled on the router itself. Mach, well, actually the G code from Mach 3 can send out signals to, or from Sheetcam, sorry, can send out signals to change the spindle speed if your machine has a spindle on it. However, most of you probably don't have $25,000, $30,000, $40,000, $50,000 machines that have spindles on them. So more than likely you can just ignore this dialog. You don't have to change it to 0. It'll just get ignored in your G code because your machine doesn't have a spindle. Same thing here with this generate name, or you can leave generate name, sorry, checked. The spindle rotation here, you can just leave it at its default. So this is ready to go. I just click OK, and at this point nothing changes. I'm just wanted to set up my tool correctly. Now, in order to generate a G code to cut this file, we go down to the operations menu, and this top little icon, it says, when you mouse over it without clicking anything, it says create a new contour operation. And what we want to do is exactly that, a contour cut of this thing. So you click this button and it opens up a new dialog box giving you a whole bunch of different choices. We're going to use an outside offset, meaning the bit is cutting on the outside of this template or outside of the material to leave the remaining part perfectly the right size. An inside offset, the bit will be on the inside, and the outside of this material will be what would be your usable template, which is useful in some cases. But in this case, we want to set it as an offside offset. The layer is board. Snocad always exports, whether you're exporting a ski or anything out of it, the layer that you're concerned with is called board. You just choose that in your dialog box here. It's usually the only one if you're doing a Snocad file. If you're exporting out of another CAD package, you may have a zillion different layers and want to cut various layers at different times, so you can choose the layer that you want to cut individually here. The tool is selected. You can choose, I've got tool 2 and tool 3 on my machine, but I'm going to choose tool 3. It was already set up. The start depth, 0 millimeters, corresponds to the top of the material the way I have this machine set up. So 0 is the top of the MDF. So when you set up the Z-axis on your machine, you want to zero it out on the top of your material, and that will correspond to 0. And then it's going to cut below that material whatever depth you specify here. In this case, it's also set up for 1.4 millimeters like that other dialog box was, where it was set up the last time I cut for cutting base material that was 1.4 thick. In this case, we want to change it to 12.7 because we're cutting 12.7 millimeter thick MDF. Depth per pass means each time it goes around this shape, if it's set up at 1.4, it's going to go down 1.4, and then it'll go down another 1.4 millimeters deeper, then deeper, then deeper. So this would take 9 cuts of 1.4 millimeters if you look down here, and then 1 cut of 0.1 millimeters to cut this overall 12.7 millimeter thickness. That's crazy talk. You don't need to do that. I would just set this at either 1 or 2 passes around for 1/2 inch MDF. I usually just do 1, so I'm going to change this to 12.7 millimeters. Here, finish allowance of 0. You could change that to leave a teeny bit of material on the bottom of this, like 0.1 millimeters, so it doesn't cut all the way through. But I usually like to cut my templates all the way through, or maybe 0.1 millimeters finish allowance there. Feed rate, again, I set up the bit at 22,000 millimeters, but you can override that here in this particular contour cut by changing it to 2,500 or whatever here. I'm going to change that back to 2,000 here. And the plunge rate is, again, how fast the machine drops vertically into the material as it's starting to cut. I'm going to leave it at 300. Ramp angle, spindle speed, I can just ignore. And you'll notice now the cut sequence is just 1 cut of 12.7 millimeters. It'll go around the shape once, and it'll cut out the template in 1 pass. I click OK, and now you notice some new stuff lights up on the screen. It's a bunch of arrows that show the path of the bit is going to take around the material. And then this blue line going up from 0, 0 on my machine, which is at the bottom left, up to there is where the machine's going to start. Sheetcam just has kind of a wizard that arbitrarily decides where it's going to drop into the material, and in this case it's sort of up on the upper right tip of the ski. There's some parameters in here you can change to drop that in a different location, but I just usually leave it at the default. And that's all there is to actually generate the code. Now, to export this code into actual G-code file that you can then load into Mach 3 or whatever cutting software you have to do a third step. And that is up here in the little P icon up here is the Postprocessor, which in this case, if I mouse over it, it shows it as Mach 3. Or you can go File, Run Postprocessor. And I'm going to just go File, Run Postprocessor, left click that button. It's going to open up a dialog box where you want to save the file. I'm just going to save it again in my Documents file, and you notice that it just automatically named the file as 173 ski outline, but it has the G-code file .tap. The extension is tap. My particular machine is set up to use tap files. Other machines may have NC or other different file extensions here, but tap is what my machine is set up for, and typically what the many machines are used that use Mach 3. Anyways, if I save this, I now have a G-code file suitable, or it will export a G-code file suitable to load into Mach 3 to actually cut the template or part that we want to do. So I click Save. And then it gives you a little completion, or this can actually be an error message. In this case, it says post-processing part, blah, 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 post-processing completed, and there's no errors. However, if you run this and then there's a red dialog box under here with a bunch of text in it, you typically will say error, and then the machine will give you some sort of a hint as to what the problem is. If you set up the Z wrong, it might say file will cut into the table. If you've got a radius incorrect or something incorrect, it'll actually give you a hint of what you need to go back and fix in your file. Sometimes it's hard to figure out what's wrong, but in this case there's no error, so I'm actually done. And this file is ready to cut out of Mach 3. Now we can do the same thing with the other two files. I'm not going to go through that again because it's exactly the same process as we just did. Alright, the third step after you've finished exporting your G-code out of Sheetcam to actually cut your template or file is to load the file into Mach 3 and actually set it up to cut. So close out Sheetcam. Yeah, I might as well save the default tool set. And I'm going to go to my Mach 3 icon and load it up. If you have one of our CNC Multicutter machines, instead of the different choices here, one will just say CNC Multicutter. But in this case, on this particular computer, I've got the Mach 3 is where my setup is for my CNC router. I'll just click OK. And that'll open up Mach 3. Again, I'm not going to go into a lot of detail of all the setup of Mach 3. We're just going to sort of show how to load a file in and get it ready and start it cutting. Typically when your Mach 3 opens up, it has some sort of an error message, either a limit switch or a no shuttle detected type. That's typical of the machine, and if you click reset, and as long as after you click reset you have no message down here, that means everything should be talking to the router correctly, and you should have no problems with your file. So click reset first. I often like to hit the tab key, which opens up my virtual joystick over here on the right. If I want to move the router head around to set up my Z-axis depth, etc., etc. But that's not crucial at this point. To load the file that we just did, we're going to go File, Load G-Code, and then we're going to navigate to our My Documents folder, which is the default place this actually happens to look at. And you'll notice here the 173 ski outline tap file that we created is here. I select that and hit OK. And you'll notice now that it opened up here, and in the little machining window here, you can see a ski outline, and then a pink crosshatch that indicates where the actual router bit is on my table right now. And you can see it's way up on the upper left near the start point of the ski there where the file is going to start. What you want to do very first thing is you want to let the machine know where 00 is. If you haven't already indexed your machine, you want to do that now. And on our CNC multi-cutters that have auto limiting on them, what you do to do that is click the Reference All Home button here, and then it will move the router head down to 00 and reset X and Y to 0. So we'll go Reference All Home and click the 0 out to, so I've got 000 showing here. Now typically I set up our Z-axis on our CNC multi-cutters to be a manual one, so you will have to manually set the Z to the top of your material by hand using your joystick, and that's demonstrated in another video. I'm going to assume that your Z-axis is set up correctly here and ready to go. So you'll now notice that the crosshatch is down on the bottom left corner of the machine, and that's where 00 on our particular routers and most CNC routers corresponds to the bottom left corner of the cutting area of your machine. You'll also notice on the menu over here that the 173 ski outline tap file is loaded in the code window here. And if I scroll down this is all the G-code data that was generated in Sheetcam. And in this case, it takes 1,700 commands to cut this template file, all the different geometry locations while it's cutting the arcs and corners and stuff on this file is 1,700 different cutting commands. So this is essentially ready to go. And what you want to do is turn your dust collector on, your router on, triple check that everything's set up and looks correct on your machine, and then all there is to it is to click this Cycle Start button. It'll start running the code, and you should see the router start moving, your actual router start moving, but also this dialog box that's the visual indication in the software as to what's happening will also start moving. Now I'm just doing a virtual simulation on this, so when I click Start, you're not going to hear the router making a bunch of noise and cutting and everything. I'm just going to do a simulation here. In other videos I will demonstrate the router actually cutting stuff, but for this particular video we're just going to do a simulation. So I'm going to click Start, and you'll see the code starts running, and then you'll see the crosshatch here slowly starts moving up to the top left corner. And you'll notice it's moving pretty slowly. 2,000 millimeters per minute here in the feed rate is not a particularly fast cutting speed, but again, with the particular motors and frame stiffness, material stiffness and blades and everything, that's a decent cutting speed for the CNC, and it's only going to take about 2.5 or 3 minutes to cut this whole template out. But for this video, that it might seem like an eternity. Well, this thing takes 2 or 3 minutes to just go around this little file. But nonetheless, I'm going to demonstrate that, and it's getting to the initial point at 0, 0, and now you see the z-axis drop down, and it's starting to actually cut counterclockwise around this template. Typically, you set up most routers and CNCs to cut counterclockwise so that the bit is rotating the right direction into the material, so you don't get kickbacks as much. So it's typically a counterclockwise cutting direction. And you see the router is just slowly going around the perimeter of the shape according to the G code that's running by. And the first side wall is pretty much, or side cut is pretty much done, and it's approaching the tail of the ski, and it'll cut around the perimeter of the tail and continue up the right side wall of the ski to the nose, or right side cut of the ski. And the elapsed time since we started, it's about 1 minute and 45 at the time I said that anyways, and it just keeps an elapsed time, and when the file completed, it'll actually give us the total elapsed time it actually took, and that'll give you an idea of what a typical template or base material file would take to cut. And as I said, it's typically about 3 minutes at this cutting feed. You can go a little faster or a little slower, depending on what your machine and bits and material will allow. We're about 3/4 done the file now, and it's approaching the nose of the ski. And it's at the end of the side cut and cutting around the tip of the ski template here. And when it reaches the end, all it does is stop, and then you'll see the z-axis will raise up to 30 millimeters, which is what I defaulted in the code, so that it'll lift 30 millimeters off the table, and it's done. 2 minutes and 45 seconds. Not too bad to cut a template. A heck of a lot faster than doing it by hand. Anyways, for cutting the other templates, exactly the same process. You load the file in, make sure everything's indexed correctly on your table, hit start. You should always have your hand on your emergency stop, just in case the router does something unexpected. You can stop it before you damage the machine, your template, or the table. But other than that, that's pretty much all there is to it. Going right from Snocad through Sheetcam, through Mach 3 to either a finished template or part.